Hi everyone and welcome to another lecture for Agricultural Engineering 311. So up until now we've been looking at micro irrigation. We've just finished a section on filtration. So today we're going to look at automation, which refers to doing things that could have been done by hand or by people and now being controlled by machines. And it's a very important part for any farm to go forward, is to look at automation and doing things and saving then that costs to covering people now through machinery. So automation is manual controlled systems are hampered by long working hours. So you are on a farm, you usually work long hours, especially during harvesting season, and now you have to pay your workers because they have to work long hours. And so when you have a machine, you don't have to cover those costs or overtime costs, and reliable and competent labor is getting scarcer and more expensive. So automation supplies more accurate control over scheduling of irrigation, and it leads to an increase in the quality and quantity of the yield, and it's more reliable. So instead of having someone determine for themselves when to irrigate, we now use automation, and you can precisely determine when your crops needs any excess or any extra water, so it helps you improve the quality and quantity of your yield. So there are three types: mechanical, electric, and computerized systems. If you look at mechanical, hydraulic kind of system, so you've got hydraulic valves and they are combined with water meters. And so at the beginning, when you are starting to irrigate your block, you can set a certain amount of volume that needs to pass through your valve, and after that amount of volume has passed through one valve, then the valve will close and you'll move on to the next block. And so you've got a specific amount that needs to go into that block, and then after that volume of water has passed through, then it closes automatically and moves to the next block, and so on until the whole cycle is finished. So that's mechanical hydraulic kind of system. Next we'll look at electrical hydraulic. So the big difference between mechanical and electrical is, in your electrical hydraulic system, instead of it being a volume of water passing through your system, now it's time based. So you'll maybe irrigate a block for somewhere between 3 or 6 hours, and then it switches to a different block. So where it was based on volume for mechanical, now it's based on a certain amount of time before you move on to the next block. And then when that set time elapsed relay is activated, which closes the valve, the program activates the next valve to open. And the advantages of using your electrical kind of system is installation is easier than a hydraulical system. You have control from a central point, so there's a central point with a computer basically that from that point you can control the whole system, and lower capital cost as computer control system. And then your wires are vulnerable to damage. That's a disadvantage. Volumetric is more reliable than time scheduling, and with more reliable, it just refers to you actually know exactly how much water you're applying to a certain part of your system. And then another disadvantage is theft sensitive for lightning. So theft is a big thing, and as well maybe lightning can occur. And then your final one is fully computerized. So now you are basically using the best of both your mechanical and electrical system. You have a volumetric kind of system where it measures the volume of water that's moving in conjunction with time control, and the total control from computer with continuous feedback from sensors and meters. So what that means is you've got sensors and meters in your soil, and those meters and sensors in your soil, they determine the shortage of water in your soil at any given time. So that's maybe using a neutron meter or any of those kind of systems. that you have in your soil to measure if there's any shortage in water, and that information gets sent back to your computer, and your computer can then calculate for itself where you need to apply water. It can also pick up things like if there's a burst pipe in your soil, it can pick up immediately that there's too much water moving out of your system at that specific spot. So it's a very handy thing to have, but it is, as you'll see at the disadvantages, it's extremely expensive. So the highest capital outlay, high level of management and expertise, and special service maintenance, and sensitive for lighting. So just also what can happen is it's a very complicated kind of system. So to make sure that the farmer or farm manager understands the whole system is usually a disadvantage, because you have to make management decisions on the spot sometimes, and to understand what your database is sending you back. It's important for your farm manager to understand how the whole system works. So the advantages, it's most effective in terms of getting water to the plants that need to be irrigated. Central control, so there's a central computer or an app that has all the information, and then prompt action and peace of mind. So next up, we're looking at installation, and we'll start by the installation of your laterals. So it's important to install your laterals exactly as it's on the plan, because you've got certain pipe diameters and positions of your laterals that correlate to the type of emitter that you're using and the volume of water that you want to give. So it's important when it's been calculated that your laterals need to be laid out in a specific way to stick by that. Your laterals can be buried, or it can be connected to a wire, so then it'll be in the air, it's going to be off the ground, and then when it's buried, there's a block or stand is used to hold it in position in a specific area. And it's important to prevent soil or borings from the pipes. So that's when you're installing your pipes underground, make sure that you don't have extra soil while you're busy burying it into the ground that comes into your pipe, because that soil can then lead to blockages as well as borings. So if you are sawing through your pipes in order to get them a specific length, make sure that the borings don't end up in the pipe. Then flushing. Flushing needs to be done when you install a new system, and that just means that you're sending a lot of water through your pipes to make sure that your pipes are clean. So you do that with your oil piping, 15 to 20 minutes for the main line, and then your manifolds, so your other pipes, are then 5 to 10 minutes before they are used. Next, your filter station is check the pressure on the filter station after flushing, and then set your pressure control valves. So if you remember from the filter part of the module, when you are using filters, as the filters get dirtier, the rate at which the water is moving through your system slows down. So there's a difference in pressure. So when you have cleaned your filters, or you have a new filter that's just arrived, then measure your pressure so that you know that when that 10 kilopascals of pressure difference is coming. And then irrigation material, treat all threaded parts against rust. Paint all exposed UPVC piping, so that's piping that is maybe in the sun the whole day. Then valves, filters, and control equipment must be protected from the sun, and deterioration of materials will happen when it's in the sun the whole day. Evaluation of installation, and that's just after you have installed everything that needs to be installed. You have to make a checklist for yourself to go and check everything and make sure that it's in working condition, so that you know that installation has been successful. And then here's just a list of things that you can go through when you're checking your installation. That's the inlet pressure at the blocks, emitter pressure and delivery, system layout, equipment, your schedule of blocks, general installation, operation of equipment, and your system capacity. And now management, which I think we can go through in the next video.